and preparing their knowns and getting started on it. And almost everybody is getting to where they want to pick up the unknown for experiment 2. You should have your equations all done by now in your books. As soon as you get your last precipitate for the tin test, you run up here and do your quiz, get your unknown, and go through the unknown and move into experiment 3. And I said for convenience for experiment 3, we'll leave out the manganese and we'll leave out the nickel. Nickel, I said, we'll do a separate experiment. And I went through, and I'm not going to do all this again. Notice we start off with 15B for the known, but you don't have to start off with 15B for the unknown. The B part just reduces the volume so you get to a reasonable size sample that you can work in the test tubes. The unknown is always going to come in 6-drop portions. Okay? Then we're doing the ammonia, the extra 1 drop of extra that doesn't bring down precipitate is the excess drop. Then we're doing the ammonium sulfide. We have to worry about the fact that it makes a colloidal suspension. That's one of the reasons I left nickel out of the known, because that does cause some problems with colloidal suspensions. Okay? Then we went to procedure 16. Use HCl to start for your unknown, because frequently it dissolves everything. That doesn't work. You go to the mixture of concentrated acids, HCl, HNO3, the aqua regia mixture. And now everything should dissolve except sulfur. And people keep missing when I say except this or that, because whenever you get sulfur, it's not one of the metal cations we analyze for. It's an element, and we're going to, when we get to the anions, we're only going to analyze for anions, not for elements. So whenever you make sulfur, you're going to discard it. And so you keep boiling and replenishing until all that's left is a yellow precipitate of sulfur. And sulfur always comes out yellow. It's this is one of the things where it forms that little lumpy thing. But several people had that happen to them in procedure 7. Because it was the same basic thing, in the last part of procedure 7, where you're trying to do the test for the mercury 2 ion, you're trying to dissolve HGS. You're using the aqua regia mixture. The oxidizing agent here converts any sulfides to sulfur. Sometimes sulfur is finely divided, like when you're making your precipitates, and it tends to form a colloidal suspension. But other times, as the heat changes, it clumps together and forms that sticky, lumpy mess with the other precipitates sort of mixed in with it. I wouldn't say dissolved, they're just mixed thoroughly. Okay. So when you're doing these treatments, you always replenish with the appropriate acids. It was actually the aqua regia back there also. Until finally, the only thing that's left is the yellow lump of sulfur. Procedure 7, if you have a gray precipitate left after you've been treating with aqua regia, the message is you didn't treat long enough. Okay? Over here, you're going to have all the ions in solution. I did those equations for you. And then you're doing 16B, sodium hydroxide. And there's one thing I do want to point out to you in here. I forgot to do that last time. But midway through the procedure, it says, after you've added the sodium hydroxide, you made it strongly alkaline with 8 molar sodium hydroxide. It says that the quantity, if you get so much precipitate that it's really solid or almost mushy or lumpy or whatever, in other words, you can't see the fluid, it says add 10 to 20 drops of water. Instead of 10 to 20 drops of water, you want to add, for each drop of water, 1 drop of sodium hydroxide. So if you're adding 10 drops, It would be 5 drops of water, 5 drops sodium hydroxide. You don't want the sodium hydroxide concentration to get reduced. So he says just add water, and I said add a mixture of water and sodium hydroxide at that particular step. This might happen mostly if you have a large amount of iron or something in your unknown. For medium amounts, it doesn't get too bad, okay? Unless you did a calculation. Then the other thing you were adding was hydrogen peroxide. The key thing you were looking for, which might be hard to see, which is why I suggested doing the test by taking some of the solution out of your casserole, centrifuging it, and then adding the hydrogen peroxide. And this brings me back to a general statement here, because I think several people are messing up on this. You add a reagent, and it turns color right where the reagent goes in, and the color goes away. What does that tell you? Add more reagent. The reason the color went away is as it got mixed with the rest of the solution, the reagent was used up, and so the thing that was causing the color change has been used up. So you add some more. Where is that important? Because I don't think this is where I think I'm seeing what people are bringing me for the cyanide test. In procedure 9, when it says make it distinctly alkaline, you add a little bit of NH3 and it turns dark blue, and you stir it up and the dark blue color goes away. So you add more ammonia. You stir it up, it goes away, you add more ammonia. When do you stop adding ammonia? When the whole thing is turned a dark blue, and you keep adding ammonia until that happens. If you see the color change right at the top when you add a reagent and the color disappears or gets lighter, it means you haven't added enough of that reagent. So you keep adding it. So the same thing back here when you're adding this hydrogen peroxide. The reason you're taking it out of the casserole is because of the black precipitates that have formed when you add hydrogen peroxide. In other words, the cobalt 2 hydroxide goes to a black precipitate. The manganese 2 hydroxide goes to MnO2, which is a black precipitate. And with the black precipitate in the casserole, you can't see this color change. Once you've decided that you need more hydrogen peroxide, you add some to the casserole also. Put this back in the casserole. Okay. And what we talked about this morning, these are the complex ions, and they're all tetrahydroxides. I did all of this. So I'll just remind you that they all have 4 hydroxide ions. Tetrahydroxyluminate 3, tetrahydroxyzincate 2. These are the oxidation states. The tetrahydroxychromate. And the thing that's green, this is the reaction I talked about. This is yellow-green, not real bright green grass. Maybe burned out grass. But this is yellow. And you've all seen the chromate color. Oh, you're going in there? Okay, so you've all seen the chromate color. That's what you're looking for, and this is an important step so that when you go to do the aluminum test, the chromium isn't there to interfere with it. Because if you don't do this conversion, this ion does exactly the same thing that aluminum ion does through all the next steps of the procedure. Coming back to this thing, you have your precipitates. I'll write the higher oxidation states. This is what gave you the black. Oh, the one thing I forgot back there in 16A, oh yes, it says 30 seconds, and that's it. I already mentioned this. It's going to be a lot longer than 30 seconds in most cases. But you have all these precipitates. Now you're adding H2SO4. I said this already. Hydrogen peroxide. Here, hydrogen peroxide oxidized the cobalt 2 to the cobalt 3. It oxidized the manganese 2 to the permanganate ion. In an acidic solution, it reduces these two things back so that they go into solution. I told you about combining the two equations here on page 212 to get your net ionic equations. But now you're going to have, after you do all of this, there should be no solid. If there's solid, you centrifuge, decant, save your decantate, and treat the solid with some more of this. If it doesn't dissolve, you throw it away. There's nothing that belongs there. Everything should dissolve. And now you're going to have a mixture of both of these things. This is going to be mostly cobalt 2 because you've reduced it back. And what I said you do with this, 4 equal parts. And you won't have nickel, and you won't have manganese in your known because I said don't bother putting those in. But when you do your unknown, one of these is for the iron test, one is for the cobalt test, one's for the nickel test, and one's for the manganese test. That's the sequence they do them, so that's the sequence. I want to see all these things. For the nickel, you're just going to do a separate test. I talked about the specific precipitating agent, dimethylglyoxime, and it makes a unique precipitate. The only thing I said is when you calculate the drops of nickel, you use the usual formula and divide by 4, just so it corresponds to what you did here, where you divided the solution into 4 equal parts. So you don't want to put that much extra nickel in. And for the manganese, what you can do is prepare a known and run it alongside your unknown test. And again, you'll use 1/4 as much. Okay? But you don't have to prepare a known for me because it's going to change color just like the permanganate did when you were sitting here doing your kinetics experiment. Now, for the iron test. Procedure for you, because it's still part of procedure 16, is it? No.
Yeah.
Procedure 17, sorry. 17 is where you dissolved it. So this is part of, this is 17 right here. And this is part of 17. Because it says take 1/4 of that solution, and then you're going to add thiocyanate ion. Except here's a correction. It says KSCN. And you won't find it because all we have is ammonium thiocyanate. Okay, so that's the first thing. You're adding 1 or 2 drops. If the color's getting darker, you add another drop, the same as the check for completeness of reaction. So you want to get the maximum dark red color. Notice again, just like we were talking about this morning, this goes in stages, and so some books put a 4, but we've added so much excess thiocyanate that this is the major one. Okay? And the iron 3 also makes it complex with thiocyanate, but I don't think it's as dark as the iron 2 complex. And notice when you did this reduction here, you reduced most of your iron 3 back to iron 2 also. Okay? Now, first thing is, what the heck is the name of this? And everybody says, okay.